Say you found an exciting project that you want to try to execute on. How do you work with an AI team on this project? In this video, you learn how AI teams think about data and therefore how you can interact with AI teams to help them succeed on a project. Now, there is one caveat, which is what if you have a cool idea, but you don't have access to an AI team? You don't have access to any AI engineers. Fortunately, in today's world, if either you yourself or you can encourage some of your engineering friends to take an online course or two on machine learning or deep learning, that often will give them enough knowledge to get going and make a start of an attempt, make a reasonable attempt on these types of projects. So let's talk about how you can work with an AI team. First, it really helps your AI team if you can specify an acceptance criteria for the project. I've done a lot of work in automated visual inspection, so I'm going to use that as a running example in these few slides. Let's say your goal is to detect defects in coffee mugs with at least 95% accuracy. So that can be your acceptance criteria for this project. But 95% accuracy, how do you measure accuracy? One of the things that the AI team would need is a dataset on which to measure their accuracy. So a dataset is just a set of pictures like these, together with the labels with the desired output B, that the first two coffee mugs are okay and the third one is defective. So as part of your specification for the acceptance criteria, you should make sure that the AI team has a data set on which to measure the performance so that they can know if they've achieved 95% accuracy. The formal term for this data set is called a test set, and the test set may not need to be too big. Maybe 1,000 pictures will be just fine for this example. But if you consult with an AI expert, they can give you a better sense of how big the test set needs to be for them to be able to evaluate whether or not they're getting to 95% accuracy. One novel part of AI systems is that the performance is usually specified in a statistical way. So rather than asking for an AI system that just does something perfectly, you see very often that we want an AI system that performs at a certain percentage accuracy, like this example here. So when specifying your acceptance criteria, think of whether your acceptance criteria needs to be specified in a statistical way, where you specify on average how well it does or what percent of time it has to get the right answer. Let's dive more deeply into the concept of a test set. This is how AI teams think about data. AI teams group data into two main data sets, the first called the training set, and the second called the test set, which we've already talked a bit about. The training set is just a set of pictures together with labels showing whether each of these pictures is of a coffee mug that is okay or defective. So the training set gives examples of both the input A, the pictures of the coffee mugs, as well as the desired output B, whether it's okay or defective. And so given this training set, what a machine learning algorithm will do is learn, in other words, compute or figure out some mapping from A to B so that you now have a piece of software that can take as input the input A and try to figure out what is the appropriate output B. So the training set is the input to the machine learning software that lets it figure out what is this A to B mapping. The second data set that an AI team will use is the test set. And as you've seen, this is just another set of images that's different from the training set, also with the labels provided. The way an AI team will evaluate their learning algorithm's performance is to give the images in the test set to the AI software and see what the AI software outputs. For example, if on these three test set images, the AI software outputs okay for this, and also okay for this, then we would say that it got 2 out of 3 examples right. And so that's a 66.7% accuracy. In this figure, the training set and test set are both only 3 pictures. In practice, both of these data sets would be much bigger, of course. And you find that for most problems, the training set is much bigger than the test set. But you can talk to AI engineers to find out how much data they need for a given problem. Finally, for technical reasons, some AI teams will need not just one, but two different test sets. If you hear AI teams talk about development or dev or validation sets, that's the second test set that they're using. The reasons why they need two test sets is quite technical and beyond the scope of this course, but if an AI team asks you for two different test sets, it's quite reasonable to try to provide that to them. Before wrapping up this video, one pitfall I want to urge you to avoid is expecting 100% accuracy from your AI software. Here's what I mean. Let's say this is your test set, which you've already seen on the last slide. But let me add a few more examples to this test set. Here are some of the reasons it may not be possible for a piece of AI software to be 100% accurate. First, machine learning technology today, despite being very powerful, still has limitations and they just can't do everything. And so you may be working on a problem that is just very difficult, even for today's machine learning technology. Second, insufficient data. If you don't have enough data, specifically if you don't have enough training data for the AI software to learn from, it may be very difficult to get a very high level of accuracy. Third, data is messy, and sometimes data can be mislabeled. For example, this green coffee mug here looks perfectly okay to me, so the label of it being a defect looks like an incorrect label, and that would hurt the performance of your AI software. And data can also be ambiguous. For example, it looks like this coffee mug has a small scratch over there, and it's a pretty small scratch. So maybe we will think it is still okay, but maybe this should actually have been a defect. Or maybe even different experts won't agree if this particular coffee mug is okay and should pass the inspection step. Some of these problems can be ameliorated. For example, if you don't have enough data, maybe you can try to collect more data, and more data will often help. Or you can also try to clean up mislabeled data, or try to get your factory's experts to come to better agreement about these ambiguous labels. So there are ways to try to make these things better, but a lot of AI systems are incredibly valuable even without achieving 100% accuracy. So I would urge you to discuss with your AI engineers what is a reasonable level of accuracy to try to accomplish, and then try to find something that passes both technical diligence as well as business diligence without necessarily needing 100% accuracy. Congratulations on finishing all the videos for this week. You now know what it feels like and what it takes to build an AI project, and I hope you start brainstorming and exploring some ideas. There is one more optional video describing some of the technical tools that AI teams use that you can watch if you wish. But either way, I look forward to seeing you next week, where you learn how AI projects fit in the context of a bigger company. Look forward to seeing you next week.